All right, so here's our third slide. We're at 40 times magnification. We're going to go up to 400. So there's 100. There still might be a little bit of movement. I can't tell. All right, let's go to the next one. Now, what's interesting on this one, do we see the same columns that we saw in the last one before we did anything with it? No, we don't.
It looks like...
Now, it could be just because it does kind of look like spaghetti. It's a good description. All right, should we try it there?
Go back to the last one. I want to see it from like...
Last one, zoomed out a little more?
From 100 maybe?
Like that?
Yeah.
You want to add the salt water there?
Pure water. Yeah, pure water.
All right, excuse me, pure water. We're doing pure water. All right, we'll do the pure water there, and then we'll zoom in, because I want to be able to make comparisons between what we watched before. All right, now, of course, we're going to see the torrent, right? It's going to be like a flood. And let's see. It'd be better if I do it from this side. Seen any movement yet?
Yeah.
Here it comes. Oh, this is, look at that.
Oh, cool. It's going down.
Not kind of.
It's going side to side, straight up and down. Whoa, okay, never mind.
It's got quite a bit on the edge. The problem is there's not enough to draw it across with those Kim wipes like I described, but I'll try it anyway.
Well, it works so well. Yeah.
Oh, here you're getting a little bit more now.
No, here it comes.
It's kind of like a dry sponge. It takes so long to wet a sponge, but once it's wet, you squeeze it out, and then it soaks it up real quickly. That's due to cohesion.
Here.
You know what it's kind of
They're doing
reminds me of?
a maze. Yeah.
Like, when there's like a tornado or whatever, and it's really calm, and then all of a sudden it's just whoosh, and everything just disappears.
To me, it almost reminds me of those videos where you see people singing, but everything's in reverse. Like the words are straightforward, but everyone's walking and moving in reverse. Oh, now it's really coming.
It's like zombies. It's like zombies closing in.
It's like a Coke commercial.
Oh, like the bubbles in Coke?
If you use the thermal camera to record what it looks like on Black Friday, this is what it looks like.
Yeah, true.
Oh, they're all coming through now.
Two sides, one against each other. Try to follow one.
That's really cool, isn't it? Look, it's almost like a cardiovascular system. It's almost like there's vessels guiding or channels.
And somewhere stuck. Yeah, what's it look like?
Now I'm going to go ahead. I'm going to shift to 400. That's at 100 times magnification. Let's try 400.
Whoa.
Those look like hexagons.
Yeah, they're kind of see-through. They're like roly-polies.
They do look like roly-polies. And do you notice a difference in shape?
They're
big.
Already you can see they're puffing up. You're getting osmosis going into the cell because the area of high concentration of water is outside, low concentration of water is inside. If you follow the solute, wherever there's more solute, that's where water wants to flow. There's more solute inside than there is outside because I put pure water on there, right? Pure water has a very low amount of solute, high amount of solvent, the water. So water always wants to flow where the solute exists. So in the last slide, the last video, we took recording of the salt water where the high amount of solute was outside the cell, so all the water exited the cell. In this video, the high amount of solute's in the cell, so you're seeing things fill. And if I left this long enough, you would actually see cells burst. If you injected into your veins pure water, you would see your cells explode. And so that's why you have a large intestine to absorb that water into the bloodstream slowly over time to be able to meter out that. And if you get too much water, your kidneys then start dumping it into your bladder, right? So you have ways to maintain homeostasis as an organism. But let's say you're a single cellular organism like a bacteria floating in a lake or a bacteria floating in the ocean, right? One is fresh, one is salt water. All organisms have to have adaptations for handling osmosis, water wanting to flow across that membrane through the aquaporons when it's in the human cells. Yeah, question. Oh, both of you guys got questions.
Well,